Okay, in this video, I want to just take you through basically these two math formulas here and how they basically work, and not really how they work because that wasn't at all explained to us. We were given this formula, understanding that this is the magnitude difference and that this is the intensity ratio. So I mean, no need to put I's and M's anywhere, but just to be specific, I guess. And we have this just a value thrown at us as an intermediate between this being shown as an exponential. But um, just want to show you the conversion from that to that, and backwards and forwards, I guess. And really, I can just show you one way. Once you could do it one way, you could do it the other way. So we're going to take I subscript A, I subscript B, and the 2.512 is actually it's an estimation, but in reality it's actually 10 to the power of 0.4. If you do 10 to the power of 0.4, okay, to understand this clearly, you will get 2.512. And let's do it, I guess, just for giggles. Where's Excel? Alright, so 10 to the power of 0.4, and you can see it's an estimation, and it keeps going on, but 2.512 is pretty close. So, but I prefer using a more accurate value. So let's continue working here. Have to draw it again. So that was I, A, I, B is equal to 10 to the power of 0.4. Alright, so in that we also have this multiple within that exponentiation. Oh, looks like I'm drawing an eye there. Of m magnitude B subtracting magnitude A. Alright, so to get started, we need to get this 10. Let me see, get that 10 here to the other side. So let's go ahead and do that. And the process is actually simple. We should be familiar with the converting from this an exponential to a logarithm. So if I wanted to know what y equals, and I have nothing but x and a to work with, I could do y is equal to the base, or the logarithm base of the letter a here in this example of x. So that's how basically that works. And of course, that's what you have to remember. You have to consider that a function of a logarithm, and it's not like it kind of like a sine and cosine. But anyway, I hope you know what I'm talking about. Let's continue on. So in this example, it's going to be log, and base 10. I don't have to put the number 10 here because when there is no base, it's understood to be 10 anyway. It's like a default value. So log of that I, A, I, B. Alright, so now 0.4 is left over here. 0.4 multiplied by MB minus MA. Alright, so here, now that was the whole exponential, just like the letter y here. It's now equal to that. And now we could get 0.4 and take that now to the other side. So usually, since from basic mathematics, if you're multiplying over here, you divide over there. but in this case I prefer converting 0.4 to a fraction, which is well, one way of doing it is putting it over 1, because anything divided by 1 is just the same, and you put a decimal here, and then let me see, in that if you do the same thing on the top and bottom, you don't change the number, so you can multiply 10 and 10 on the top and bottom, which gives you 4 over 10. So that's that as a fraction. 4 over 10 times the mb minus ma equal to the log of blah. Don't feel like writing it over again. So I multiply on both sides by 10 over 4. That 10, oh, let me use a different color. That 10 cancels out with that 10, that 4 cancels out with that 4. So now our formula so far is 10 over 4 times logarithm of the intensity IA over IB, which is equal to the magnitude difference. Now, you may not see it right now, but that's the same exact thing that we have so far. You can see the magnitudes and the logarithm and everything. Only thing difference is 10 over 4, and if you decide to do 10 divided by 4, it is 2.5. So 2.5 times the log. So just taking it step by step through the conversion may help you understand the mathematics behind all of this a bit more. I know, at least it does for me. So MB minus MA. Alright, so that's pretty much the video. So in the next one we'll discuss going ahead and taking doing one of the math problems using these formulas, and we won't get too crazy. Alright, see ya.